All right, here's another think, pair, share to give you some more practice. This is on poplar tree soil treatments. So the table below lists weights in kilograms of poplar trees that were given different treatments at different sites. Use a 0.05 significance level to test the claim that the trees with different treatments have the same mean weight. All right, so we've got this table of data. Um, so this is organized in a more calculator friendly manner because now you can just kind of enter list one like that, list two, list three, and list four. Um, and with the numworks, if you're using the MyOpenMath, you can just kind of enter these values separated by commas, carriage return, value, comma, value, comma, value, comma, carriage return, and so on. All right. Um, so, you know, our null hypothesis is going to be that the mean for each of these is going to be equal. So the mean of no fertilizer should be equal to the mean with fertilizer. That should be equal to the mean weight, poplar tree weight under irrigation, and that should be equal to the mean poplar tree weight under fertilizer and irrigation. And that's going to be our original claim. Okay, computer is frozen here. Now the alternate hypothesis is going to be that not all means are equal. And I'll write that down when my computer is done thinking. There we go. Okay. So the alternate hypothesis is that not all means are equal. Okay, so let's go ahead and let me scroll down here. Okay. Yeah, my computer's struggling to keep up. Come on. There we go. Okay. So let's just maybe go ahead and draw in our F distribution. I'm just going to draw it as though it were right skewed with a right tail. So this is our critical value. Now our significance level here in this one is 0.05. The region above the significance level, that is our reject the null region. Above the confidence level, it's fail to reject. All right, now to calculate this critical value, we're going to need degrees of freedom of the numerator and denominator. So we've got to go ahead and do the ANOVA calculation first. Okay, so we'll go ahead and come over to the Texas Instruments. I've already entered in the values for no fertilizer or no treatment, fertilizer as a treatment, irrigation as a treatment, fertilizer and irrigation as a treatment. And if I've entered this in correctly without any errors, now let me go to stat and I'll go to tests. I want to do ANOVA, enter. And I have four lists. So it's going to be list one, comma, list two, comma, list three, comma, list four. Oops, I didn't put a comma. You get so excited. All right, hit enter. All right, so we have a test statistic of 5.73, a p-value of 0.007, degrees of freedom of the numerator of 3, and degrees of freedom of the denominator of 16. All right, let's go ahead and write those down. So we have an F test statistic of 5.73. a p-value of 0.007, degrees of freedom of the numerator of 3, and degrees of freedom in the denominator of 16. All right, let's check that with the numworks equivalent. So we'll go over to my open math. And you can see I put in the values, as they pretty much occurred uh, in the table itself. So going across the top, this was the row 1 for no treatment, 0.15, fertilizer, 1.34, irrigation, 0.23, and fertilizer and irrigation, 2.03. So I put a comma in between each column. And at the end of the last column, I hit enter to go to the next line, and I entered the second row, comma, enter in the third row, comma separated. So now I can just hit submit, and we get a test statistic of 5.73, p-value of 0.007, degrees of freedom of the numerator of 3, and degrees of freedom of the denominator 16. I put this D1 and D2 because that's what it says in the numworks calculator. Okay. All right, so we got the same values as before. Now, one thing I haven't mentioned yet is that if you just want to clear this, if you want to clear this to just have it free, I mean, you could select it all and hit delete, but if you put try a similar question, see, it all goes away. Okay, so that's a way to clear that. With the Texas Instruments calculator, I don't know if I mentioned it before, but if you have a list in your list editor that's full like that, and you want to clear it all, if you go to memory, so memory, you have to hit the blue second button with the plus button. Make sure you go down to clear all lists, okay, and hit done or execute. And now when you go to the list editor, it'll all be empty, okay. That saves you, if you've got a bunch, going to each one and clearing them out. You can kind of do it all in one fell swoop. Okay, so let's go back to what we got going here. All right, so now we need our critical value. So to get our critical value, we have to use an inverse function. So let's look at numworks first. We want to go to the distributions app, go to Fisher's F. Okay, degrees of freedom of the numerator is 3. Notice it says D1. And degrees of freedom of the denominator, it says D2, that was 16. And we want the area to the right, where the area is 0.05, because we have a 0.05 significance level. There we go. So we get a critical value of 3.24. So let's just kind of confirm that here. So program inverse F83, significance level of 0.05, degrees of freedom of the numerator of 3, denominator of 16. The critical value is 3.24, same value. Okay. So we have a critical value of 3.24. And we have a test statistic of 5.73. So 5.73 is going to be above 3.24. So this is going to be our F test statistic of 5.73. So going up from that point, we are in the reject the null region, and the area adjacent to the test statistic, that is our p-value, and that's 0.007. And if the p-value is smaller, which it is, reject the nuller. Okay, so both indicators are both showing that we're going to reject the null. So now we just have to write our conclusion. So the null hypothesis was our original claim, and We're going to reject the null. All right, so let me see if I can scroll down a notch or two. Okay, wait for this to finish. And yep, it did that again. So, okay. All right, so we will reject the null. Okay, reject the null, and the null is the original claim. So this is going to be our outcome, write our conclusion. There is sufficient evidence to support rejection of the claim that okay, come on. There you go. Okay, the claim that the poplar trees with different treatments have the same weight, and that's going to be okay, with a 5% significance level. Okay. And that is our conclusion. All right. Let me know if you have any questions.